My name is Valerie Marie Weaver. I'm a professor at the University of California, San Francisco, Department of Surgery. I'm have the pleasure of giving a talk in one of the major symposia in the upcoming AACR annual meeting in Chicago. I would love to say too that it's the first time that the AACR has recognized the importance of forces in cancer. And the title of the session that I'm speaking in is Tissue Mechanics and Physical Forces in Cancer. It's on Sunday, April 27th, 1 to 2:30 p.m. I've been studying, my group has been studying the extracellular matrix of the connective tissue and how that plays a role in cancer risk, cancer aggression, and therapy response. And one of the things that we really focused our efforts on is that what people don't recognize is that cancer is a physical disease. This is how it was recognized way back in Egyptian times as cancer of the crab. And basically where we've been going with our work was we could show that it actually drives tumor aggression, it drives growth, it drives motility, it drives metastases, et cetera, et cetera. But what we've also realized in the last decade, we've been doing a lot of work on the interplay between the connective tissue and forces and the immune response. And what we're finding is, first of all, the immune system actually drives some of the fibrosis and mechanical changes in tissues that drive cancer. So that's number one, that is pretty important. And number two, the immune cells now respond to the altered physical properties of that connective tissue. And they actually have their whole anti-tumor response corrupted. It changes their metabolism, it changes the microenvironment, it changes availability of metabolites so that the T cells can't survive, can't do their job. It makes the myeloid cells pro-tumorigenic, which is precisely what you don't want, right? That's not a good thing. Now, more recently, what we started to realize is in addition to changing the metabolism and changing, the matrix and the, anti-tumor function, what it also does, the matrix is also making those myeloid cells produce a lot of reactive oxygen species and lipid aldehydes. Now, why is that important? Okay, the reason that's important is because lipid aldehydes cause DNA adducts and DNA damage. And what we're finding is that it drives mutations in the cancer tissue. And that's not a good thing. That's actually really bad. Okay. Now, where we started moving with this, of course, it can contribute to tumor heterogeneity and the mutational load of tumors. But we started asking is, could it drive cancer? Could it initiate cancer? And could this explain why there's such a huge relationship between inflammation, chronic inflammation, and cancer? And the answer is that's at least part of what's going on. And what we find is women with BRCA mutations or women that have high mammographic density, they have a stiffer, more mechanically challenged breast tissue, for example. And that actually, we are finding evidence of mutations. We're finding evidence of DNA damage. We're finding very, very profound increases in lipid aldehydes in those tissues, which is actually not a good thing, right? So the big key then is to try to understand like what we can do about this, because you can't change your connective tissue. I mean, you could try some of that. There's some treatments and things that you could do to try to calm things down. It certainly is a very poignant argument for, for anti-inflammatory diets and for, trying to actually, create a more holistic, healthy lifestyle. But what would be really important is that we could figure out, could we use some of this to actually as novel diagnostics? Could we use this for developing novel treatments? How do we correct the behavior of those corrupted myeloid cells? That's really the key point here. And I think that's where our research is going. And I would be like delighted if people would come and attend the session. I'm one of 3 speakers. And I would end by saying, to ignore fluorescent cancer is like trying to treat cancer half blind. Thank you very much.